Hello, this is Dr. Moberly. We're going to look at a worksheet from December 11th. This worksheet has both the z-scores and the t-distribution, the student distribution. And for the left column here, you have both the alpha over 2 and the 1 minus alpha. So if you're talking confidence intervals and the amount that's left in the two tails, so this is the two tails approach, and we're just going to work with the two tails. And for the student t, there's also the degrees of freedom, which is one less than the number of number of elements in the sample. Alright, and for this first one, we're looking at an unknown variance, and that right away tells us that we want to use S and the t distribution. So let's look at the sum of our samples. This is a big S. Sum of the samples is going to be 7.540 plus 7.064 plus 1.528 plus 5.587 plus 3.678 plus 1.767 plus 071 plus 4.838 plus 7.899 plus 8.203. That's equal to, let's get back to here, that's going to be 54.175, and we're going to divide that by n, and n in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sample of 10, and so that's going to be 5.4175. And now we're going to do the values. 7.540, we're going to use the delta, which is going to be 7.540 minus 5.4175. That gives us 2.1225, and we're going to square that. We've got 4.505, and I'm going to go ahead and add that to a memory if I can. Don't remember if there's a mem plus. Maybe it is. Okay. 7.064 minus the 7.064 minus the 5.4175 gives me 1.6465. Square that, I got 2.711. Add that to the memory. 1.528 minus 5.4175 equals negative 3.8895. Square that, I get 15.128. Add that to the memory. 5.587 minus 5.4175 equals 0.1695. Square that, I've got 0.0287. Go ahead and add that to the memory. 3.678 minus 5.4175 equals minus 1.7 395. Square that. 3.026. Add that to the memory. 1.767. 767 minus 5.4175 equals negative 3.6505. Square that. 13.326. Add that to the memory. 6.071. 6.071 minus 5.4175 equals 0.6535. Square that. 0.427. Add that to the memory. 4.838 minus 5.4175 equals minus 0.5795. Square it. 0.336. Add that to the memory. And then 7.899 minus 5.4175 equals 2.4184815. Square that. 6.158. Add that to the memory. And lastly, 8.203 minus 5.4175 equals 2.7855. And square that. We got 7.759. And add that to the memory. Let's pull out the sum of these. It's going to be it's going to be 53 point. Oh no, that's not right. Yeah, that is right. 53.405. And then we're going to divide that by n minus 1. Divided by 9 equals. And I've got 5.934. That's my little s value. And what am I going to use for my t value? I'm going to look for the alpha equals 0.1. So that's going to be this, alpha over 2, 0.05. My number of samples is n equals 10. So my n minus 1 is going to be 9 degrees of freedom, and I am looking at this bottom row. And so the question I want to know, my accept or fail to reject region is going to be 5 minus 3.250. So that's t, and then s over square root of n, times s, which is 5.934, and square root of 10 there, and this one's going to be 5 plus 3.250, 5.934 over square root of 10. And let's go ahead and compute what this is. Clear 10 square root, and 1 over that times 3.25 times 5.934 0.34 equals 6.099. 5 plus that and 5 minus 6.099. This is a very big region, and clearly x bar, which is equal to that, so it's minus 1.099 to 11.099, and x bar is in this window. So this is the key thing here, fail to reject the null hypothesis, because we don't have data that's far enough away from the hypothesis. It's away by a little bit, away from 5, but not by nearly enough for a sample size of 10. All right. Let's move on to the next one, which is a large sample taken from a binomial distributed population with p equal to 0.120. So the binomial variance, that's sigma equal to sigma squared equal to p hat 1 minus p hat, which is going to be 0.88 times 0.12 times 0.88. And that's 0.12 times 0.88 equals 0.1056. Let's take the square root of that, because sigma, the standard deviation, is going to be the square root of the variance, which is the square root of 0.12 times 0.88 equals 1056, and take the square root. Something's not quite working. .12 times 0.88 equals, take the square root of that. There we go. 0.1056 is going to give me 0.3249. Closer to 50 actually. There we go. And let's build. Well, I want to get a margin of error, which is equal to, in this case, z alpha over 2 and sigma over square root of n. And we know what our margin of error needs to be. So let's do the algebraic jumbling first rather than last. Let's put the square root of n over here and put the z alpha over 2 sigma over me over there. And then let's go ahead and square it, and it's got to be greater than or equal to z alpha over 2 squared sigma squared me squared. And now this is going to come from the 99%, which is this, 2.576. 0.576. Quantity squared. Sigma is 0.1056. And margin of error is 0.01 squared, which looks like it's going to be 2.576 x squared times 0.1056 divided by 0.01 divided by 0.01 equals 7,007.379, or we'll just say 7,008 samples size. Okay, so that concludes the second one, and now we're going to do one more to get another color, which will be orange, and it says here we know the variance. We know the variance, therefore we know sigma, and sigma must be square root of 10. It says here to go ahead and put together confidence limits for the interval for mu. So let's first add up, let's find x bar, which is going to be the sum of the samples over n. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples. That's convenient. Let's go ahead and add them all up. Minus 1.0 clear. 0.127 negative plus 5.786 plus 5.474 plus 7.897 plus 3.774 plus 4.506 plus 7.251 plus 7.139 minus 3.237 plus 10.094 equals 48.557 divided by 10, which is going to be 4.8557. All right, very good. We've got the mean, and now we want to look at a interval from x bar minus z alpha over 2 sigma over square root of n to x bar plus z alpha over 2 sigma over square root of n. And n is equal to 10. This is going to be nicely canceling. This will be 4.8557 minus, and the z we're looking for again, because we're taking the 99%, 2.576, 2.576, and then this is square root of 10 over square root of 10, which conveniently cancels out, and this is going to be 4.8557 plus 2.576. Clear. 4.8557 minus 2.576 equals 2.2797, and this 4.8557 plus 2.576 gives us 7.4317. And I think that is the confidence interval, the 99% confidence interval, and I believe we have finished the 3 problems on the worksheet. So I'll stop.